The feed roller is quite simple. It just sits on a couple of 3D printed rollers, just sits in place. I may put a bar across so that this thing can't come falling off at the end of the reel or something, but it works quite happily at the moment. So the take-up system is fairly straightforward. The spool itself sits on, this is a step block on the end here, just to, because the internal diameter of these things keeps changing, so you never know quite what the diameter of your reel is going to be. And then we've got, it's all 3D printed, and a 3D printed GT2, and that goes onto the motor, onto the drive. The motor's clamped in place, and I've added this lever on the side which couples to the motor and allows me, because the motor shaft is offset, it allows me to swivel the motor and then set the tension on the belt, which is really useful, so you don't have to put an idler wheel and a belt tensioning system in. We've also got a variable speed control on the system, and forward reverse should I ever need to use that. The heating system obviously is over here. We've got this coil of wire wrapped around PTF heat tube, which is stretched between two collets, which holds it sort of nice and straight. Feed the feeding reel into the top until it goes halfway down. So it doesn't really matter. All you're doing is providing a reasonable amount of length for the actual heater to work on. Once it's in position, then we put the heater on. This is drawing about 1.5 amps. 12 volts, so not a huge amount of power. That decides to go off when it wants to go off. And get it up to about 70 something degrees, and then switch it off, let it settle for a little while. So this is real time, so high voltage obviously you'll get there quicker, but I think this is a reasonable balance. So we're about, there we go, 73, so I'll leave it there now. It'll climb up a little bit further, not a problem. So we're just leaving it there to settle, and I normally give it about 20 seconds. Right, so the heating's off now, and then we put the fan on. And the fan just helps things go a little bit quicker and cools things down, so there's no danger of actually bending the soft material when you take it out. If we bring it back down to about 40 degrees, it should be adequate. Then it's nice and solid. Okay, so then we can now withdraw the filament from the tube. We pull this one out, and we've got a very nice straight filament to play with, to work with the jig, and it makes life a whole lot easier. So that's the bottom one, sorry, the top one, and then we have the same on the bottom one. Okay, so there we go. So just a closer view of the heater itself. PTFE tube, which we use on printers, nichrome wire, and PTFE tape just to hold it in place. I think there's probably about 30 turns on there. As I said before, it gives us 12 volts, 1.5 amps, give or take. So the backlight I put in is just a torch, a simple torch that just slides in place. Okay, right. Not really necessary, you get used to it, but I thought for demonstration purposes it'll be something useful. The top and bottom blocks are identical. These collets go into brass threaded bushes to hold them in place, so you can screw a nice fitting. The blocks themselves can actually move up or down, so the two screws in the bottom will pull the block down, and you do that with the top as well if you want to, and that then stretches the tube slightly and keeps it nice and straight. You can't go too hard on the stretching, because once this tube warms up with the heat, it does become a bit more elastic, and then you can just keep on stretching it and you run out of room. But generally just keeping it fairly straight is the way to go. And we've got the same thing at the top. Okay, a bit more. The thermometer is the cheapest I could find off Amazon. Comes with two Type K thermocouple probes as well, which is quite useful. So just one is actually strapped. You can just see it in the middle of the tube there, You don't have to spend a huge amount of money on this. It doesn't have to be accurate, but it does the job quite nicely. So once the joiner has been switched on and is coming up to temperature, then we can actually open up the jig. Move that out of the way. There we go. And then insert the filaments. So the filaments are fed into the jig from the top, and also from the bottom as well, going through. And I'm provided a little stopper on there, so you can push the bottom one up until it comes level, and that marks exactly the center spot of the heater bar. Once the lower one's in place, then we can just tighten up the clamp on that, and it actually holds the filament in place. The top one doesn't, the clamp is only for a guide, because you want this to be able to move up and down. So now we can swing the thing out of the way and then add our PTFE tube. I should point out that once you've actually reached the center, then I'll just snip it off, so we have a nice clean edge to work with, and that seems to work quite happily. So once the lower section is clamped, we can move the jig spacer out the way, and then add the PTFE tube that we're going to use. So everything in place for the join. The lower section is now clamped, can't go anywhere, and the top one can actually move slightly, which is what we want to make the join. So now we just need to move the whole jig in place. It'll actually place it exactly in the middle of the heating element. Close the flap. Wait for the beep as we've instructed. Open it up. And now we can just gently pull it out of the way. This is such a whole lot easier than trying to do this, because you need 3 hands, I think, to open the clamp and hold this, and hold it in position while it cools off. I've got a fan to put on this as well, but I haven't actually installed that at the moment. So we just let it naturally cool for about 30 seconds or so until it's come down. So to withdraw it, we just undo both clamps, allow the back plate to slide out the way. There we go. So we've got that all done and dusted. And now it's a question of cutting off the tube itself, so I'll do that next. So tube in place, and then as you would do normally, just cut the tube, and away we go. Difficult to see, it's such a good joint. I can feel it there just with my fingers, but you can't actually see anything going on. So there we go, that's been a success. So the system works quite well. It's a bit iffy in places. It needs some refinement, but generally proving the point of the heating system to give you nice straight ends to play with when you're actually joining does make a huge difference, rather than trying to fight the curl of the filament, especially at the end of the reel when it goes really, really tight. And then you try and do it by hand, and it just doesn't seem to work correctly. I have found a secondary benefit of this. When I'm feeding the MMU, if the filament doesn't come in exactly lined up or wants to go from one side or the other, then it gets jammed or just won't get into the MMU itself. It's a real pain. You have to keep twisting the filament to find the right angle for it to go into. With this system, you can actually do a nice straight end, and it'll feed directly. And since I've been doing this, I've had absolutely no filament loading problems whatsoever. Other times it can be a bit literally hit and miss. The way that Prusa designed the feed or the take-up system to actually get the thing into the MMU could have done with some refinement to give sort of wings either side of the entry tube to stop the filament from moving to the left or right, and which is where it gets jammed. And this principle in actual fact could be used with this selector on the front of the MMU, because when you're trying to unload filament after you've run out, when it goes back into the selector, then it just hits whatever's there. If you're lucky, it'll go through. Sort of, in my experience, about 9 times out of 10, it just won't go through, and you have to do it all manually. So that's been quite useful.